Hello, this is a continuation of the Tusker Blueprint project demo. And in the last video, I have already given an introduction about how a Tusker Blueprint, we have created a blueprint type of project which will help, which is showing that how a platform engineering system using Backstage and AgroCD, how that GitOps and Backstage works together to automate your entire developer onboarding workflow, and also a typical development workflow. Even it can be a developer, normal developer logging in, or an AI-based copilot working on it, how to set it up, and that can be used for your entire testing purpose. The entire workflow was given in the previous video, how a developer can get a system, and later when you update any change in the forked repository or clone repository, how the entire flow will work, doing entire flow, including testing, unit testing, and also doing that different compliance checks and comes out. That was the previous video about Tusker Blueprint. In this video, I'll be focusing more into the observability part, which is almost at the end of the system, like after every development is done. But I thought just giving the end-to-end workflow and focusing more into how these type of systems can help the telemetry, or maybe I am not going too much into the theory part of the observability. I hope you know about monitoring, telemetry, and also observability. So here I'm going to show exactly how a complete observability, obviously it includes telemetry and monitoring, and how that system works to find out a customer problem, and how that can help your entire team to make your uh, customer support or finding a resolution, predicting the problems. These type of things can be made faster. So there are a lot of tools used. I'll be trying to cover in a very simple manner how all those can work together. I have made everything done on a remote machine, and I have connected all those. I have forwarded all the ports into my local laptop, and then I am giving this demo. So let me share my screen quickly, so that you can directly find out what and all are running on this machine. So this is a repository which is currently open source, as I already mentioned, and I am doing live development. At least I will be doing some more development here based on the feedback, some more feedbacks I received, and you will be finding all those how I develop. This also made with all documentation. So even you can use it and enhance it further with your AI Copilot if you want to add any further features or anything. You can also contribute back to this project. Now coming back to the actual topic, this is about the telemetry part of this. So I have right now enabled monitoring, including the health event, health checks and everything. You can see all those. This is what the actual dashboard for this Codon Path Tusker Blueprint project. You can find out like most of this details, like how is the system doing, and these and all coming from the demo application. So I have in the background, I have the systems. Let me just show you all those running in the background. So I am just doing basically all the forwarding of the ports, and I have all these services running in the remote machine. And whatever, if you recollect the demo I gave for the Tusker Blueprint, you can find out that these and all are the demo application, like each developer is working on it. Whatever is with the extension minus development is something which is used by the individual developers. You can assume there are three development teams working on it. And this is something which is a live application. I right now I'm using this, and this application is right now getting monitored for the demo. And how why of this application? This is just a very uh, just a simple application to have a feeling about how the entire workflow goes through. So I am now going to forward this particular application from which is running on a remote machine to my laptop. So I have all the scripts ready and kept it on this. So I just need to run it accordingly. So to save time, all are scripted and automated. So I'm just running it over here. I'm just setting a environment variable which has all the Kubernetes parameters. I'm now, let me go to the project repository path, and this contains the demo. So right now I forwarded this. You can find now, you can see this is what the application. It is very simple notification and notification application just for a demo purpose. I kept, you can treat it as your own application, like it could be banking, it could be health, or any of those type of services. You can assume it like that. And here I am going to show you that this set of graphs. So this is a action monitoring graph which talks about different situations. It just gives the different status of your systems. It could be, it is all self-explanatory. I'll just make it quick, like it is telling about what's the release it's running, how many replicas of the application, how many requests. This right now I'm counting even the health checks. That's the reason I'm running it for some 20 minutes now. And if you start your laptop, it should automatically come up also. And this is just measuring P95. I hope you, if you look at SRE, from SRE background, you know what this means. Just giving latency and those type of details are getting captured here. So and these are the actual services, which is right now I have not done any demo load. I'll be executing a demo load by which you will be able to get all these are getting populated. And this is about tracing part. So this will give a set of tracing. This will give internally I enabled tempo tool, which is part of this Grafana tool chain, and that will give the tracing, like whether what was the application status. It is mainly doing instrumentation for this demo application and giving the status. And this is what this overview, how is latency, and also your platform engineer, whomsoever is monitoring the system, can have like these boards on your have, I mean, if you are doing I2 class monitoring, have like these boards scrolling in your screen. That should be sufficient, and it should give your information, like anything if it is going wrong, it should be able to give that in your dashboards. Right now it is looking all green. Now I'm going to introduce some errors and also giving you some delays, so latency issues and all. I'm going to introduce with by doing some creating some problem in the cluster. Right now everything is running smooth. I'm now creating and also going to create a huge traffic by which you will get to know what is there is something going on wrong. So let me introduce some errors. And here, so the errors are here. I'm just keeping this, making it a bit more, creating a setup which is going to create errors. The containers are now going to be made. So now I'm working out this. Obviously, it is running internally. It is just rolling out the replication. And now I am going to also introduce a lot of traffic. I have a script for that. Obviously, it is also open source. So this will create a. So what happened was, like, now the application is not getting forwarded because internally what happened is, like, it just changed the container. So I need to again do a port forwarding. So I am doing again. So now the application is running, but now this time this is with some errors. See, there are some errors and all are coming. So now let me just start again the traffic. So now you can see that what is happening internally is, like, it's creating three types of queries, but those are with errors. So you will gradually see these graphs are going in a, yeah, you can see that API success was failure. So it actually did not execute anything. So the success, there are a lot of failures happening. You will see that there is a, for example, internally your application is having some problem. For example, you are deploying a new service, new version was introduced, and there are a lot of requests coming, but nothing is getting served. So you can see the success percentage is low. So this is how it happens when if any of the applications going wrong, something like you can start seeing the red colors. Now I'm going to introduce some bit more errors. So let me just show you that. Instead of errors, I'm going to create a latency issue, the slow response. So I'm going to now restore this to the previous stage. Be patient. You will be getting to know. It's a demo I'm giving, so be patient. But I'll explain what is happening. So this is this I right now. What I'm going to make is like I'm going to make an application to look same like. I mean, right now it is brought back to the same good state. For example, you had a problem, and so this time I reverted the release, or there is a fixed applied for the release. So now that application is back, and now it is ready. So you can assume that your application is back to the normal state. And now you will see that the things which was going bad, this is a tracing log. And now the success percentage also will gradually increase. See, it is 93.668. So like that, it you will see that it is now gradually coming back to normal. So this is how the monitoring system, it's an average taken. So you will find out. So I think I have multiple. Yeah, let me just do the creation of traffic. Now I started creating traffic. So you'll see that this one continuously it is hitting this application. So you will gradually see a change in the applications metrics, and you will see that all those different types of traffic coming into this. You can see these and all are real notification traffic. You'll see it has started monitoring. It is increasing now. So now the traffic got increased, and you can see that gradually it is started serving. You can get to know that how much of type of notification. This is just I just make it very clear that this is coming out of this small demo application which has 3 types of notification implemented. Just a trial application which is getting captured over here. So the traffic demo traffic, whatever I have created, dummy traffic I have created, it's mainly trying to send an SMS. Trying to execute a webhook and trying to execute send an email. So this time it is all getting served. I back to normal. Previously, if you remember, it was all getting failed because I made purposely the container to send it. I mean, not to serve the request. It was like a error. I mean, application with error. So it was able to capture easily because you can see that the application, the colors got changed in the dashboard, and there is nothing moving, nothing. It's all like applications. And because there is a lot of, you will also get to know like there is a lot of traffic now I created, continuous traffic. So you will see that it is also giving the problems. There is a lot of CPU load, and also a lot of in memory. So if there are some records are taking time to respond, that is also coming over here. But gradually you can see that the application is coming back to normal, and the success rate also getting improved. You can see it over here. It takes some time because previous execution took a lot of time, and because of that, I mean, I executed. There are a lot of failures. So from red, it has become orange. And so this is how a regular telemetry system works, like how easily you can have a look at. You can also send alerts by looking at this from here. If there is a problem happening, you can connect your PagerDuty to it, and then that can also give alerts to you. So regular SRE system is what I am showing over here. And if you want, you can have a look at the code. Like I tried to make it more simplified. Again, I'm telling this is very basic how things are working, and obviously you can enhance this traffic, this board to whatever additional features you want. And regular SRE, Google SRE book you can refer. Then that will give you a lot of information. And now I've done. I think now I have done made it back to the regular. Made the application to go to success. So now let me try to make this application to have some create some slowness or create a latency delay in the response. So that is also a measure. Like if there is a lot of load happening on the application, what we normally do is like we have to regularly monitor. Like for example, there is sudden surge in the traffic, so you will have to have your backend running and to take care of the, maybe you have to do a scale up, do some add additional resources. It could be using automated scaling, scale up, horizontal scaling. You have to do all those factors. Even your Kubernetes can handle that, but these type of mechanisms will help us, your team also, to monitor, ensure that things are working. So P95 latency is the one which is normally used like normal standard measurement, like out of 100 requests, at least 95 should be delivered on time. So that is what it means by P95 in very simple terms, but that itself is a very long item to discuss. So now you can see that a lot of traffic here are coming. System is able to find out like a lot of traffic is going on. And now this time I'm going to introduce parallel, one more set of traffic. Right now everything is happening once in a second. So I'm trying to make it more in a regular scenario, like how it is actually happening. And I will also show you how the tracing works. Tracing is like if there is any application is going wrong, if you want to find out what's the actual reason. So this is how the tracing works. Like if anything is not working, you can search with the trace ID, and that will be giving you like this details. It's internally using Tempo database, or it is like an application which does not require a special database. You can read more. There are a lot of videos available. I don't want to repeat the same. But yeah, Tempo is a tool which is used internally for tracing purpose. Tracing is something like if you have an application, you will keep your marker in between your application, and it will be just keep on sending the signals like how long it took here, this application took. That can be monitored like based on the timestamp. This application took this much time, this it took this time for this one. That's how, in very basic terms, that is how it actually works. Same regular instrumentation mechanism is used over here. Now coming to the creating a latency. And then finally, I'll show you one real use case where a customer is able to, I mean, there is a customer problem and how we are able to tackle that and find out there is a, how will we find out where is the issue happening. So next, what I'm going to introduce is like creating a latency intentionally. And now let me patch the demo application with some latency issues. So this is what I just, I'll just run this in a way that it can do that work. So it's just going to roll out. You will see that it is getting reflected over here. You can see that gradually it has introduced some problems. You can find there is a latency issue happening. There is a delay. Now I have to restart this port forwarding. Now you can see that it has now started the application, and now I have to start giving it traffic. So I'm going to give a traffic now. Continuous demo traffic I am going to give. And maybe I'll make it bit more detailed. Detail means bit more extra traffic, 2 times traffic. You'll find out like now, right now it should go in a very gradually. You'll see success is still orange because if you remember beginning, I have given a lot of errors. So it is taking the 30 minutes average. Obviously, I can change it to 15 minutes, or you will find, let's say, 5 minutes. You'll find out that it is for past 5 minutes. It was because I made the container in a good shape. And for this demo, I'm now always changing it to 5 minutes so that you can easily get to know reflect. It will reflect exactly what happened in 5 minutes, as 5 minutes time. So you can see that it will gradually increase this response time. It's 5 milliseconds. Obviously, my machine is not bad, but it will take even heavy load. But I made the container to act in a very slow manner using a simple code so that it can be used for a demo. So you can see that the entire lag is going on, and there is some delay, of course. And I'll show you. You'll see that. Yeah, see, you can see that the response when in a bad shape. There is a It has changed into 3 seconds. If you remember, it was a millisecond earlier, 5 millisecond. Now it has 3 second delay. Obviously, that is a problem. So you can see that it has come to a red color. Obviously, it's a problem. So it is mentioning there is an issue. And you can also find out these things, what's happening in the background, like what is a traces talking about. So you can see that there is a problem happening over here. You will also get to know easily from here what is the issue. I made it transparent. What is the problem with that? This is what the message is getting passed. But overall, you will see that you can trace what's the issue. You can also find out from here what's the duration. If you closely watch, you will get to know each of this operation, how long it takes. So now you will see that the entire graph is going in a very bad direction, bad way. Obviously, I have made a lot of a lot of load. That is the reason there is a lot of traffic. And let me just at least stop one. There are two executions of dummy loads happening. So at least now it should reduce a bit, but still it will be having latency issues. So, but this is how actually the system works. You can see that as a human, if you want to just observe, even if you want to use an AI system, you can connect with this. Just have a monitoring happening in the background, and then you can act on it, how it is actually working. So, and now to give a demo, the final one. So I think it is overall, it is clear like how it is working. So I'm now bringing back my system to the normal state. So for that, I'm just doing this demo, no failures. That I'll should bring back to the same state. Only thing is like it will restart the container. In the background, Agrocity is also running. So yeah, it has killed the container, and you can understand that it has created a new container with changes in that. Now it is brought back to the same older working container. So now it is executing the traffic. So now let me just execute the traffic again. So let's see how it goes. So now you will gradually see in next 5 minutes. It will take 5 minutes to give actual demo, but you can understand that, yeah, things will be coming back to the same state where you will see that this will gradually go off, and if the container is performing well without any latency issues, all these graphs also will give similar information. You will see that how it is able to perform this. So after some time, you can see that the latency also got corrected, and it'll come back to in millisecond state. So let's see how it goes. So in the meantime, I will also give one traffic, which by which I'll give a query also, a particular message from a customer. For example, an order is given by the customer, and that we should be able to track. So I have given a name like this, correlation ID, which is like a unique number for a request. So I'm now going to give an execution, or I'm doing a curl command. It's like an API call I'm going to make, and that should give, it should create an entry in the application log like this. So if a customer is coming and telling you, oh, I have a problem with my, I'm not able to access your application, you should be able to track it like this. Just check search. So you'll see that there was an application like this running, and it has all these problems. And what was I mean, right now there was no issue. Things went well. But if anyone is complaining, you can get to know that whatever is coming out of your application as a log, it is all getting captured over here. Right now, I'm just printing all the details, but you can see that I mean, I just mentioned here as a filter, you can find out like it is working, and I can track. So this is what I actually called. You can see that correlation ID and all details, whatever very basic details I am printing. Since there was no issue, it is not giving any errors, but normally if there is any application log, those can be attached with the error format, and that can give a detail. So right now, the application is running, and you can see that P95 is also getting reduced. I think there is another two places traffic is running. So here is one parallel to traffic. Okay, I think it is only one. I'm just giving a traffic now. Yeah, you can see that it has come back to green color, and it has come back to the same state how I started this demo. Right now the application is you can be happy, you can feel it happy, all green color, and in between it is also capture like during this process and their cycle, like I created a lot of load and all problems, and how much time the memory, how long in some cases what was the peak load, and how much of records, how much of request was pending. So this information also can be used in the future to find out like how your application performs in the bad state. You can see that how much of application is getting what type of applications, different type of notification. Obviously this is nothing but these are presented in this way in a graphical manner, but this is how overall distributed tracing is tracing the application. Again, this is how the real world scenario, very simple application tracking or tracing is happening using Tempo, the tool which is used internally. You just go through the code, you will get to know how it is actually working. And you can have a look at also, if you can easily implement it and have a look at. So it will also give you all those type of errors tracing, and you can track that what's happening. All those things are whatever is coming over here. You'll be able to get to know like how it is performing. Your application is performing, how the load is going on, and average load, peak time load. All those details you can get. Underlying, if you're finding that things are happening very smoothly, it is obviously running with Agro CD. We are using GitOps over here, and in their configuration, including the configuration used for the Grafana, is also whatever graphs I am shown over here. You'll find out, or even the code. It is all, everything is kept in the code format. There is nothing manually configured over here. If you want to modify something, modify in this file. You can also use your AI systems to modify if you are new to this, or you can directly, some of these things I have written manually. But I have ensured that all are documented well in a spec-driven development format. So you will be able to find out how it is working and go through this video if you are not aware about Tusker Blueprint project, and it explains how things are working over here. And if you have a query, please contact me. And I will also add some more videos about this very soon, about how the architecture is there, how simple it is to understand. Even though it is looking very complicated, actually it is made it simple. In bigger organizations, some organization I have found it is very complicated way all these are designed, but there is no need to make it so complicated. Things can be made it simplified. I am sure I made it more simplified, and just giving a demo. I don't want to include too much of theoretical part of each tools. Please go through other videos. A lot of contributors are there with all these tools. You can easily refer that, or just search. You will get to know what each of the tools does, and the structure of the. It is also all explained over here. How things are working, how logs are getting captured with Loki, how the authentication is working, how Prometheus is collecting, how Alloy tool is working together. All are configured in a very simple format, and with documentation is mentioned over here. So please go through this and share your feedback. Thank you very much.